Assalamu alaikum friends, welcome to my channel. In the last video I had shown you the simulation of this structure, and today I am going to show you how to calculate the birefringence and dispersion from this simulating value. And for calculating this we need these two equations, where birefringence is the difference between X polarized light and Y polarized light, and dispersion is the 2 times differentiation of refractive index with respect to lambda. Now we will go back in the Comsol again. For calculating dispersion, we need to vary lambda, like as we can get different type of refractive index by varying the lambda, and for varying this we can use parametric sweep, but I did not prefer parametric sweep. For this I will vary the lambda in manually. If you want to use parametric sweep, then you can use it like this: parametric sweep, where where you can vary pitch, lambda or diameter, etc. If we use lambda, then we have to use lambda, and you can give the value list from this, where start, step and stop options are remain, and you can give and you can put the value in there like 1.3, 0.05, 1.6. Then you can add it, and you can give parameter unit. Then you have to compute it, but as I did not prefer parametric sweep option, so I will delete it. Yes, and I will vary the lambda from this option. Here I have used the lambda 1.55, but here now I will use the lambda 1.3, 1.35, 1.40 and finally 1.6. So let's start. Now I will write this 1.30. Then compute it, and it takes sometimes. We get one mode. This may be X polarized mode or Y polarized mode, but we need two mode, so we have to change our source mode. We can check it. For computing the values, it takes some time, and we have to wait as usual. We get the values. Yes, we get two two modes. This is our first mode and this is the second mode. But here we can see these values are same 1.4156, 1.4156. So we cannot tell this is X polarized light and this is Y polarized light. We can check it by arrow surface. Okay, now we will check it. Okay, plot. Actually, this ray should go along this line or along this line. But here we can see light ray is bending a little bit. So for this, we will assume that the last mode is the X polarized light and this is the Y polarized light. Okay. Now we have to go derived values, then we will get global evaluation. We can rename it like this: X polarized light, X polarized from X polarized light we can get two type values, real value and imaginary value. Similarly, from Y polarized light we can get two type values, real and imaginary part. For and for the real value we have to write in effective like this, and we have to change the unit and we have to make it maximum. And here is the option effective mode index selection. Here is here is the options and we have to take from list, and this is X polarized light. Then we have to evaluate. This is our real number for X polarized light, and we can get the imaginary number just removing it and write it I make. Then evaluate it, and this is our imaginary part. And if we click on this, then we can get this type of options, and from this we have to select, we have to copy table to clipboard, and the values are copied and we can write it uh, we can write wavelength, and this is X polarized line, X polarized real part, and this is X polarized imaginary part. As we have copied the values from Comsol, and here we will paste it. this is the real value of X polarized light, and this is the imaginary part. And here is the wavelength of 1.3. Next we will take for 1.35, 1.40. So for taking the other values, we have to go in Comsol again, and here we can see, but here we can see light ray is bending a little bit. So for this, we will assume that the last mode is the X polarized light and this is the Y polarized light. Okay, now we have to go derived values, then we will get global evaluation. We can rename it like this: X polarized light, X polarized from X polarized light we can get two type values, real value and imaginary value. Similarly, from Y polarized light we can get two type values, real and imaginary part. For and for the real value we have to write in effective like this, and we have to change the unit and we have to make it maximum. And here is the option effective mode index selection. Here is here is the options and we have to take from list, and this is X polarized light, then we have to evaluate. This is our real number for X polarized light, and we can get the imaginary number just removing it and write it I make, then evaluate it, and this is our imaginary part. And if we click on this, then we can get this type of options, and from this we have to select, we have to copy table to clipboard, and the values are copied and we can write it uh, we can write wavelength and this is X polarized light, X polarized real part, and this is X polarized imaginary part. As we have copied the values from Comsol, and here we will paste it. This is the real value of X polarized light, and this is the imaginary part. And here is the wavelength of 1.3. Next we will take for 1.35, 1.40. So for taking the other values, we have to go in Comsol again, and here we can see and here is the X polarized light. So we need to calculate the X polarized light by global evaluation, and we can rename it Y polarized light. Friends, I think this video duration, the duration of this video will be long, so please you need to take some patience. And here we have to the and here we have do the same things as we have done in the X polarized light. Here we will and here we will do same thing for Y polarized light, and we will get the real value, and after that we will get imaginary value. We have gotten the X polarized value, and we will copy it and paste it into another table, and we will make another table for Y polarized light like this. This is the option for real values, and this is the option for imaginary values of Y polarized light. Here we will paste the value. We will get the X polarized value and Y polarized value for lambda 1.3. Then we need to vary the lambda 1.3 and assume it 1.35. Then for this we need to calculate the values in the same way. So we have to go in Comsol again, and we need to change the lambda. Here we have to write 1.35, and again we have to compute it, and I think it takes some time as before. Here we get the value one is X polarized and another is Y polarized. So we have to do like before, and we need to find the values, and we have to go in derived values and go in global evaluation option, and here we will take X polarized light for the lambda 1.35. I will write just X. I think you will understand this. And make this an effective where change the unit and make it maximum, and take the last value. This will be X polarized light, evaluate, then imaginary number I make, then we will copy it and paste in this. For Y polarized values, we can write it like real, then imaginary. Copy it, then paste it. In the same way, for 1.40, 1.45 or other, we need to follow this. Just to show you how can you vary the wavelength, and you can vary the wavelength in this way like this. So I think you can do for the other wavelength. So for plotting the graph in the next, what should we do now? We should do now in go to in Excel. From this we can copy this paste it into Excel. Then copy this column and paste it into Excel. At first, I think it will be boring to you, but when when you can capture this option, then it will be easier for you, and then you did not take much time. And from this we can calculate the effective refractive index, and we can calculate it from polarized light from the real values minus imaginary part into the imaginary number I, like this, real minus I into imaginary, and we can write this like here the real value is remain in the column of B, and the imaginary number remain in the column of C. So we can write this B2 minus IC2 IC2. Then we can get the values, and in the same column we can and in the same column we can get the other values if we do like this. And this is the effective refractive index for polarized light, and when we have to calculate the effective refractive index for polarized light, we have to do the same. And here we can see the real value of polarized light remain in D column and imaginary number remain in E column. So we have to do like this. T2 minus I E2. Then, as we know, the birefringence is the difference between the two polarized light, X polarized minus Y polarized light of effective refractive index. So here we can get the birefringence. Here the X polarized effective refractive index remain in F column, and the Y polarized effective refractive index remain in G column. So we can write it like this. Then we get the value. Here I have just shown the for the wavelength 1.3 and 1.35, and in the next video I will show you for the other parameters. Sorry, I had forgotten that here we need to take the modulus of these values. So we can write this ABS of F2 minus G2. As the duration of this tutorial becomes long, so in the next video I will show you the other how to you take the other parameters and how can you calculate the dispersion also. Friends, if you like this video, please subscribe my channel and press the bell icon to get the notification, and comment in the comment section without any hesitation. I will try to solve your problem. So stay home, stay safe. Thank you.